All right, welcome to one of our last sections of notes for the year. This is just going to be a mini section that stands on its own, and it's going to talk about our complex numbers, or in other words, our imaginary numbers. Remember we talked about the fact that imaginary numbers exist, and that our imaginary number is I, which in other words is the square root of -1. Well, complex numbers is really just when you combine your imaginary numbers and whole numbers. So complex numbers are something that look like this. A plus BI, or a real number plus an imaginary number. They could also just be imaginary. That's fine as well. All right. So we're going to talk about how to combine and use our operations with these complex numbers. When we're adding and subtracting, even though I is technically not, we're going to treat it like it's a variable. So we can combine imaginary numbers with imaginary numbers, but we cannot combine our imaginary numbers with our real numbers. So for A, 4 plus 3 gives me 7. Then I combine my imaginaries. -1 and 2 gives me +1. For B, don't forget, if we're subtracting, we need to distribute that negative. So this is really 7 minus 5i minus 1 plus 5i. 7 minus 1 is 6, and -5i plus 5i cancels. So my answer is just 6. You can even do more than one. So let's say we're looking at C. Don't forget to distribute your negative. So 6 plus 2 minus 9i minus 8 plus 4i. 6 plus 2 is 8, minus 8 cancels all each other's out. -9i plus 4i is 5i negative. Same rule goes for multiplying, but there's one exception, and that's if you get an I squared. So remember, I is the square root of -1, which means if I was to square I would just have -1. So we're going to treat I just like a variable, and then if we end up with an I squared, we're going to change it to a -1 and finish simplifying. So looking at A, if I distribute 5i, I have -10i plus 5i squared. But remember, I squared is -1. So -10i plus 5 times -1. Which final answer? -10i minus 5. Same thing goes for if they're both real and imaginary. Only instead of distribute, we're going to FOIL. So first, outside. -7 plus 14i. Inside, last. Plus 4i minus 8i squared. Combine like terms, and remember, I squared is really -1. So -7 plus 18i minus 8 times -1. -8 times -1 is a +8. -7 plus 8 is 1. Let's do one more. Let's do letter D. First from each set of parentheses, 2 times 6 is -12. Outside, 2 times negative 2i, negative 4i. Inside, 3i times negative 6, negative 18i. 3i times negative 2i, negative 6i squared. Combine like terms. Substitute I squared for a negative 1. So negative 12 minus 22i plus 6. Negative 12 plus 6 is a negative 6. So far, complex numbers. Everything's going to stay the same as if I was just a variable, but it's not, with one exception, and that's where we're replacing our I squareds with negative 1s. Division is where it starts to get a little bit more complex. So the complex numbers have conjugates. And really what that means is that if I had a plus bi, its conjugate is that I'm just going to change the sign in the middle. So a minus bi. Or in other words, I'm just changing the sign of my imaginary number. 3 plus 7i and 3 minus 7i are conjugates. 6 plus 3i is really 6 minus 3i for a conjugate. The conjugate of 10 minus 4i is 10 plus 4i. And the conjugate of a negative I is just a positive I. Here's why those conjugates are important. Remember that I is the square root of negative 1. And if you think back to a long time ago, we talked about we're not allowed to have square roots in the denominator. Well, the imaginary number is a square root, so we can't have the imaginary number in the denominator either. But it's okay because we can use our conjugates to fix it. You're going to multiply the top and the bottom of the fraction by the conjugate that I can't spell. Of the bottom. You don't need to multiply by the conjugate of the top. It's just going to end up putting another I at the bottom. So multiply top and bottom by the conjugate of the bottom. So if I look at example number 1, my bottom is 1 minus 2i. Conjugate of 1 minus 2i is 1 plus 2i. So I'm going to multiply top and bottom by 1 plus 2i. I'm going to do them in different colors off to the side. So let's do the top in green. 5 plus 3i times 1 plus 2i. 5 times 1, 5. 5 times 2i, 10i. Plus 3i plus 6i squared. Sorry, my eyes are starting to look like J's. Backward J's, though. Combine like terms. And replace with my negative 1. 5 minus 6. So I'm going to have 1 plus 13i on top. And then let's do the bottom in red. I have 1 minus 2i, 1 plus 2i. I get 1 plus 2i minus 2i minus 4i squared. 2i minus 2i cancels. So I have 1 minus 4 times negative 1. 4 times negative 1 makes that a positive, plus 1 gives me 5. So 5 goes at the bottom of my answer. See how that got rid of the I that was on the bottom? Let's do another example. Let's do B. Conjugate of 1 plus I is 1 minus I. So I multiply top and bottom by 1 minus I. When we do the top, we'll do it in green again, just for consistency. 2 minus 7I times 1 minus I. 2 times 1 is 2, minus 2I, minus 7I, plus 7I squared. Combine like terms and replace I squared with a negative 1. Negative 1 times 7 makes a negative 7. 2 minus 7 is negative 5. So I have the top. Bottom. 1 plus I times 1 minus I. 1 times 1 is 1. 1 times negative I is negative I. I times 1 is positive I. I times I is I squared. Negative I, positive I cancels. I squared becomes negative 1. So I end up oops. I should watch my signs. This is a negative I squared. So I have a negative 1. Well, that's just 2. Negative 5 minus 9I all over 2. And let's try and squeeze in just one more example here. Again, remember, multiply by the conjugate of the bottom. So this one's going to be 1 plus 2I, but that's definitely going to stay negative 1 still. So negative 1 plus 2I. Let's do our top in red. 3 plus 11I times negative 1 plus 2I. Negative 3 plus 6I minus 11I plus 22I squared. Combine like terms and replace I squared with a negative 1. Minus 3 minus 5I plus 22 times negative 1. 22 times negative 1 makes negative 22. Minus 3 more, I've got a negative 25. Minus 5I. And then we do our bottom. Again, I'll do it in green. Negative 1 minus 2I times negative 1 plus 2I. Negative 1 times negative 1 makes a positive 1. Negative 1 times 2I makes negative 2I. Negative 2I times negative 1 makes a positive 2I. And negative 2I times positive 2I makes a negative 4I squared. Those will cancel out. 1 minus 4 times negative 1. 1 plus 4, which really just makes 5. And that's it. So remember, your complex numbers are a combination of real and imaginary. You can just treat I like a variable, except for when you get I squared, you're going to change it to a negative 1. And you're not allowed to have I at the bottom. So you have to multiply top and bottom by the conjugate and simplify. Oh wait, hold on, I noticed. This answer is not simplified. They all divide by 5. So our final answer should really be, which is really just negative 5 minus I. Don't forget to simplify like I did. Have a good day.